Guys, in this video we are going to see an example of three-phase circuit. Here this question is asking, in a three-phase balanced delta-delta system, the source has ABC sequence. The line and load Z are 0.3 plus J 0.2 and 9 plus J6 ohm. Load current is IAB 1540 degree A RMS. What are the phase voltages? Here the question is asking to find out the phase voltages of the delta system, because in the question they have mentioned this is a three-phase balanced delta-delta system. Okay, this means this is something we don't want, because if you look at a delta system look like delta-delta shape, right? From this one you can recognize. And if I draw a sample delta circuit, it's going to look like this: delta delta, and we are going to some circuit like this. From this one you can see here we have so many meshes and other things, so it's very difficult to solve this kind of system. So what we have to do is we have to convert this one into Y system, and the conversion factor is this: when we have something in delta like Y, we convert this one into delta, but here we are going to do the opposite. Since we are converting from delta to Y, we have to think it in the opposite way. Okay, now let's draw our circuit. Uh, let's draw the Y circuit for this one. And Y circuit is the bottom one. This is delta and this is Y. And from this one you can see Y circuit is going to be like some. Okay, let's draw the circuit. Okay, here we go. So let's say this is a Y circuit, and we have the voltage source. We have to find out the voltage source. That's the question. We have to find the voltage. Okay, let's say this is our voltage, and also we have the impedances provided. We have line impedance and the load impedance. Okay, and when we convert line impedance from delta to Y, it doesn't change, so we can copy the same thing. In our case, line is 0.3 J 0.2, so this is going to be just, let's write Z line 0.3 J 0.2, and the second one is load. When we convert this one into load, we have to use this conversion factor. Here you can see Zy is equal to 3Zy. This is from Y to delta, but when we convert from delta to Y, we have to do the opposite thing. We have to divide this one by 3. Okay, so if we divide this one by 3, in our case that's easy because this is just a multiplication of 3. And if we divide this given impedance by 3, this is going to be just 3 plus J2. Okay, so this is for load. Now we have the circuit. Our purpose is to find out the voltage in Y, then we are going to convert this one into delta. Okay, to find the voltage, let's think it like A to N. This is our from here to here, right? This point, let's call this one A, and this is N. To find the voltage across this one, first we have to find out the current. Okay, we have the current in delta system. To convert this one into Y system, we have to use this conversion factor. IL is equal to IL over root 3, so we have to do the opposite. We have to multiply this one with root 3 and we have to subtract 30 degree. Okay, and if we do that, this is going to become IAN, because we are looking at A to N current, and that's going to be 15 times root 3, because we are doing the opposite thing. We are converting from delta to Y, so multiply by root 3, then we have to subtract 30 degree. Okay, here we have 40 degree, and if we subtract 30 degree, that's going to give us 26 10 degree. Okay, so this is going to be the current in Y system. Now we have the current and the impedance, so we can find out the voltage. Voltage is equal to IZ, and current is 26 10 degree. Since we are looking at the voltage from here to here, we have to do the addition of impedances. 0.3 plus 3, that's going to be 3.3, right? 3.3, and then J 0.2 plus J2, that's going to be plus J 2.2, and if you calculate this one, you're going to get 103.1 43.7 degree. So this is the voltage in Y system, but the question here is to find out the voltage in delta system, right? So we have to convert this one into delta system. Now to convert this one into delta system, we have to use this conversion factor. From Y to delta, this is going to be just multiplication with root 3. Root 3 times 103.1, and then we have to add 30 degree. So 43.7 degree plus 30. Okay, and this is VAN. Okay, in delta system this is going to be VAB, because we have to think like we are picking up this one and connecting like this. Okay, so this is going to be our VAB. Let's write this one down. VAB. So root 3 times 103, that's going to give us 178.57, and then the angle is going to become 73.7 degree, and VRMS. Okay, the unit is VRMS, and this is for AB. But in delta source, like in delta system, you can see we have VAB, VCB, VAC. Okay, and in the Y system, you can see the angle clearly. The angle changes 120 each time. This one is 120, 120, 120. Here when we convert the delta, it's going to be the same thing. So what we have to do is we have to change the angle by 120 each time. So this is for VAB. Now we have to find out VBC. Also we have to find out VCA. Now to find out VBC, what we have to do is we have to subtract 120 degree angle. This one remains the same. This value in front, that's going to remain the same. Only the angle is going to change. So 178.57, and if we subtract 120 degree from this one, that's going to give us negative 46.3 VRMS. Okay, and VCA we have to add 120 to this angle, VAB angle, that is 73.7 degree. This is our VAB, and if we add 120 to this one, that's going to be, the first one remains the same, 178.57. 120, if you add 120, that's going to give you 193.7 VRMS, and these are the voltage we are going to have in delta system. And that's the question, right? That's it. I hope this helps. Thanks for watching.